Let's look at how to solve trig equations. So let's refer back to some algebra here. If we are looking at an equation like this, 2 cosine squared 4x minus 1 equals 0, we've got to learn how to use algebra to solve this. So I'm going to refer back to this. X equals pi over 16. So what we are going to do is we are going to plug in x right here. So we have 2 cosine squared 4 times pi over 16 minus 1. Okay, so remember how we have this squared here? We need to go ahead and move that out. So it should really be like this. Square. There we go. All right, so we simplify what's inside this parentheses. So that'd be 2 cosine. That would become pi over 4. And then squared minus 1. All right, so let's figure out what cosine is at pi over 4. So we need to look at our formula chart. Look at the unit circle. Sine is y, cosine is x. So x at pi over 4 is square root of 2 over 2. So it's right here, pi over 4. So I'm going to replace this with square root of 2 over 2. Squared times 2 minus 1. All right. So whenever you square that, we're still going to have the 2. So I'm going to come over here. 2. Square root of 2 squared is 2. Then 2 squared is 4 minus 1. Okay. 2 times basically 1/2 is 1. 1 minus 1 equals 0. Okay, let's go to the next one. So same thing, but this time whenever I start it, I am going to start it by doing cosine 4 times 3 pi over 16. Close all of our parentheses and then put the squared here minus 1. Okay, so we simplify the 4 and then the 3 pi over 16. So it's 2 cosine is 3/4 pi squared minus 1. So we need to look at our unit circle for cosine 3 pi over 4. So sine is y, cosine is x. So 3 pi over 4 is right here. So it is the x value, so negative square root of 2 over 2. So 2, negative square root of 2 over 2 squared minus 1. So this will be 2. We're doing squared with a negative, so it'll become positive. So this is 2 over 4. Whenever you square it, that becomes 1 minus 1, which also equals 0. To see how we're trying to get it to say equals 0 by plugging in different values for x. Okay, recall from algebra. X squared equals 2x. So we want to solve this. So whenever we solve this, we're going to get everything on one side. So I have x squared minus 2x equals 0. Then I'm going to factor the x out. Then to find my solutions, I'm going to set both of them equal to 0. So I have two solutions, x equals 0 and x equals 2. Okay. This one, very similar. I'm going to move the x over. 3x squared minus x equals 0. Factor the x out. And then set them both equal to 0. And solve. So we have x equals 0 and x equals 1/3. Okay, the next one. This one, see how there's nothing in common, so I can't factor anything out. So whenever that happens, I can go the other way and look at it this way. So I need to divide by 4. So x squared equals 1/4. So we take the square root. So x equals, we got to do the plus minus. Square root of 1. So this is square root of 1 over square root of 4, which is 1/2. So our two solutions are x equals positive half and x equals negative half. Okay, so we're going to apply that same concept here. 2 sine x minus 1 equals 0. Well, they have nothing in common, so I'm going to do it like my last algebra example. And go ahead and solve. Okay, so sine is y. So whenever we look at our unit circle, we're going to find when the y value is 1/2. Okay, so the y value is 1/2. So it would be at pi over 6 and at 5 pi over 6. At pi over 6, it's 1/2, and at 5 pi over 6, it's 1/2. So then that tells me it is pi over 6 and 5 pi over 6. But there's some wording in here that we have to pay attention to. So it says find all solutions. So that's if you keep on going around the circle. Keep on going around, multiple revolutions. So all the revolutions. So remember that one revolution equals 2 pi. So we want to go around it infinity times. So we're going to do plus 2 pi n, or let's do 2n pi. And so you have to do it on the other one too, because we'll take this one and go around and keep on going around. So then this would be the same thing. So this accounts for all coterminal angles. Okay, so let's go to the next one. Sine x plus square root of 2 equals negative sine x. Okay, let's go ahead and add a sine x. So we have 2 sine x plus square root of 2. Let's move that to the other side. Equals negative square root of 2. Okay, divide by 2, divide by 2. So sine x equals negative square root of 2 over 2. Okay, so remember sine is y. So we are looking for where is the y value at negative square root of 2 over 2. So that's going to be down in these bottom quadrants. So let's look. Sine is y. So negative square root of 2 over 2 is 5 pi over 4. And the other one is 7 pi over 4. You see it? The y values at 7 pi over 4 and 5 pi over 4. So that is here. The y value is this negative square root of 2 over 2. So that means x equals 5 pi over 4 and x equals 7 pi over 4. Okay, so we also need to account for all. So we need those coterminals. So we're going to go one revolution, or infinity revolutions, really, whatever n is. So this will be our solution. So this counts for all coterminal angles. Okay, let's go to this one. Okay, so let's solve it. So I'm going to add 1, 3 tan square root of x equals 1, divide by 3, tan square root of x equals 1/3. Take the square root. So tan x equals plus and minus. Let's see, it'd be 1 over square root of 3, which is square root of 3 over 3 whenever we rationalize it. Okay, so we're going to look at the tangent. So tan is y over x. So we're looking at whenever we divide them, we get the square root of 3 over 3. So let's look at our unit circle. So when we divide y over x, so it's going to happen at either the denominators of 3 or denominators of 6. So we want square root of 3. So we are going to look at, let's look at pi over 6. If I have 1/2 y over x, 1/2 over square root of 3 over 2. So let's look at pi over 6 would be, let me look at my formula chart. It's square root of 3 over 2 and 1/2. So we'd have to do y over x, so 1/2 over square root of 3 over 2, which gives us, if we do the work, this 1 over square root of 3, which would rationalize to be this. So we know that would be our positive, so pi over 6, so x equals pi over 6. And then the next one would be it would be the same coordinates. So see how when we divide that. So we want to look at that, but it doesn't matter with signs because this says plus or minus. So the other spot that it's like that is 5 pi over 6. And then again at 7 pi over 6, because if we divide, it's the same coordinates, just they're different signs. They're actually the same signs. So whenever you divide, you get positive. So 7 pi over 6, and then again at 11 pi over 6. So what we can do is instead of continuing to write all 4 of those, we're just going to go 180 degrees. So not a full revolution. If we have this, if we go 180 degrees, we get to this one. So pi over 6, which my image might be a little off. And then what was that other one? 7 pi over 6. So we're just going to go plus 180 degrees, so in pi. And then the other one is right here, 5 pi over 6. And then if you go 180 degrees, you get to the 11 pi over 6. So we'll do plus n pi. So then that's what x is. All right, we will do number 4 in class. Okay, so let's go to the next page. This says for 5 through 8, we are going to solve on 0 to 2 pi. So that just means one revolution. So we need to solve this. Well, this is already factored for us. So we're going to set this equal to 0 and this equal to 0. So cosine x equals 0. Cosine x minus 1 equals 0. So we want to find whenever the cosine equals 0. So sine is y, cosine is x. So we go, where is x? 0. And that's at the 90-degree mark. And also at the 270-degree mark, which is 3 pi over 2. So this one is pi over 2. and 3 pi over 2. And since we are doing 1 revolution, we don't have to do plus 1 revolution or anything like that. Okay, this next one, plus 1, plus 1. All right, so sine is y, cosine is x, so go to where cosine is 1. So that is at 0. So where is the x value? Sine is y, cosine is x. Oh, we want it to equal 1. So it'd be right here at 0. And that's the only spot because over here at pi, it's at negative 1. So we just have those two. Okay, let's go to the next one. But let's go ahead and do this. Sine squared x minus 2 sine x equals 0. Let's go ahead and factor. Okay, so sine x equals 0 and sine x minus 2 equals 0. So we want to look at sine x equals 0. So we are looking for when the y value is 0 on our unit circle. That's at 0 and at pi. So those are our two solutions. Okay, the next one, we've got to solve it. So sine x equals 2. Okay, so we are looking at sine is y, so y, when the y value is 2, let's look at our unit circle. Is the y value ever 2? The most it is 1. So this means this is a no solution on this side. So we just have two solutions. Okay, we are going to look at these two in class. I want you to go ahead and solve them, so on your own. Okay, and